Hi, I'm Logan Chen, and with Professor Maria Dainati, I made a catalog of optical gamma ray bursts. What are gamma ray bursts? Gamma ray bursts, or GRBs for short, are bursts of high energy that are more or less equally divided across the sky, and no GRB has been recorded that was within the Milky Way yet. Otherwise, we'd be extinct. GRBs are traditionally divided across two main categories: long for those that are greater than 2 seconds, and short for those that are less than or equal to 2 seconds. Their progenitors or sources are the collapse of massive stars for long GRBs, and binary mergers between neutron stars and black holes for short GRBs. They carry extremely high amounts of energy and are the greatest releases of energy in the entire universe. For context, I am making the paper of an optical gamma ray burst catalog with measured redshift, part 1. The various goals of making the largest optical GRB catalog to date, with 54,030 data points, 533 light curves, include having a uniform format for optical GRB data, having readily available resource, better defining GRB classification, better studying hidden features, better studying emission mechanisms of progenitors, and having a database to train machine learning in order to reconstruct light curves and estimate redshift. The Neil Girls Swift Observatory has 3 onboard telescopes, and they are the BAT Burst Alert Telescope, which covers 15 to 150 kilo electron volts, the XRT X-ray Telescope, which covers 0.2 to 10 kilo electron volts, and the UVOT, which is a ultraviolet optical telescope and covers 170 to 650 nanometers. Together with this Swift Observatory and 419 ground-based telescopes, they make up most of our data in our database. As a pipeline for building the catalog, there is data collection, magnitude correction, investigating the color evolution, and division into 3 groups. These are the 4 main steps in creating the catalog, and I contributed to the first 2, which I'll elaborate on later. One of the very first tasks I performed was I checked if GRBs had any data from the ultraviolet optical telescope on board Swift. So I used the Swift website, and once I searched up the GRB in question that I was checking, I would see a graph that looks like what you see on the right. The black is the BAT data, the red data is the XRT, and everything else, the colorful points, are the UVOT data. And that is what I was looking for, which I would mark down in a spreadsheet like this. Another task was, once I got that UVOT data, I would format it such that it would be easier to code and be more uniform. Something else for code is that I ran Python scripts in Jupyter Notebook, and a task I did with that was I corrected magnitudes. So I corrected the magnitudes for galactic extinction, which is like basically the scattering and absorption of the GRB in the journey it got here to Earth, or Earth sensors, or telescopes rather, and the Vega to AB systems. So I also edited the online materials tables that we have attached to the paper. So I added some AV values, which is basically the extinction data, and I also wrote a lot of citations, 1,158 in fact. Yet another task was I marked GRBs with large error bars. What that meant was they had error bars that were over or equal to 1 plus or minus. I should mention this is a light curve, which compares magnitude and time logarithmically. And on the right, you see all of the filters and the data points laid out in front of you. What I did with each GRB with a large data point was that I compiled it into a list and then restored the new data with the old data to replace that large error bar. Last but not least, one of the most important things is to check your work. So, as this is a very time-consuming task across 533 light curves, we divided it across different people and across different 4 checks to check it as much as possible. What I did was I looked at every single outlier point, looked at their source, and checked if they matched our file. If they were wrong, I would fix it and mark it down in the comments. So I learned a lot from this. I learned a lot from M3. So obviously I learned a lot from GRBs and how they are, what they even are. I learned about photometry and a few telescopes like Swift. I learned a lot about some nomenclature such as optical, extinction, and progenitor. I learned part of the process of making a scientific paper and the formalities of citing them. And I learned some online repositories and journals such as Archive and NASA ADS. And I would like to thank Professor Maria Dainai as my subject matter expert or mentor for allowing me to have this opportunity, and Ariana Riccio, Professor Lynn Komsky, and just the rest of the MTA team for making this all possible. In the future, I would like to go into astrophysics and study deep space, maybe study at University of Hawaii and IFA. But if not, I just want to study deep space and perhaps GRBs. Thank you. Any questions?